Hello, thank you for watching this AV-8B, a conventional landing demonstration video. So in this video I'm going to cover off how to correctly perform conventional landing, and I'm going to do so in a couple of parts. So firstly I'll explain what the conventional landing is and why it's important. Then I'll demonstrate how you prepare for a straight-in landing. We'll then perform the approach for the straight-in, with the key checkpoints being the long finals and the finals position. And then we'll perform the approach and the touchdown, during which I'll demonstrate how to correct a high position and a low position and a left and right position. So the conventional landing is not commonly performed in the Harrier, but if this is your first time flying the Harrier, it's really important to get used to it, as it will allow you to easily transition from any other aircraft to this one and understand its flying characteristics, as you're not also adding in the element of vertical or short takeoff and landing operations on top of that. In reality, the conventional landing is used when you have a strong crosswind, and particularly used at night, as it allows you to counteract the wind better as you have a higher ground speed. So the first thing I'm going to do is I'm going to set up for the approach. So to do this I need to do a few in-cockpit things. So firstly I'm going to come down here. I'm going to make sure that I've got my waypoint selected. I like to designate it in case I need to use it at all. And then you need to put the course line for the runway. In this case it's 245 degrees. And you need to be prepared with this information before you fly, or if you're landing at an airfield you weren't expecting to land at, you need to try and get it from the controller if possible, or consult the F10 map for that information. Next we need to put the QFE in. The QFE in this case is going to be 2930 inches for runway 24 right. Now the QFE is airfield elevation, so now instead of reading 0 at sea level, the altimeter will read 0 when we touch down on the runway threshold. Okay, so next what we're going to do, in a moment we're going to unpause, and I'm going to fly to position myself on the runway centre line as seen in the EHSD here. And I'm going to do so at 2,000 feet, and then at 8 miles I'm going to start my descent. Okay, so unpause. Okay, so we're still in nav master mode. I'm going to come left here, try and pick up that centre line, and I'm going to descend down to 2,000 feet. We want to avoid going faster than 300 knots at this point in time. So at this current moment in time, I'm using pitch for rate of descent and power for airspeed. Okay, we're at 11 miles there. I'm going to come left a little bit more, as we want to pick up that runway centre line before we reach 8 miles. Okay, whilst we're approaching the centre line, I'm going to start doing my in-cockpit check. So first of all, put ourselves into VSTOL master mode, bring our flaps to auto, and now we can bring the gear down. Make sure the nozzle's forward, stow stop's clear, water's off, and combat water is turned on. It should be turned on at the start of every flight. Okay, we're coming up on the runway centre line, 8 miles, 2,000 feet. This is going to set us up nicely for a 3-degree approach. Looking out the cockpit now, we can see the runway is just up ahead there. Let's see if we can bring that scale down a little bit. So we're a little bit off to the left, so we're going to start adjusting across. Now to set ourselves up for our correct rate of descent, we're going to checkpoint ourselves. So our next checkpoint is going to be at 6 miles at 1,500 feet, and we just want to have between 10 to 12 units of airway the entire way down. So I'm using power to control my rate of descent, and I'm using pitch to control my airspeed. So if I want a greater rate of descent, I bring the power back. So here you can see me bringing the power back. coming up on center line, roughly 1,500 feet at 6 miles. Okay, so we're getting slightly low, so if we want to adjust up, we need to bring the power on, so push the power forward to reduce that rate of descent. But in order to keep our AOA up, we need to pull back on the stick also. And we're on runway center line there, there's the runway up ahead. And we're at 1,000 feet, 4.5 miles, so we're a little bit low. This is the final point at 4 miles. There we go, we can see we're on runway center line now. Okay, so our next checkpoint is going to be at 2 miles at 500 feet, so I'm just going to reduce my rate of descent a little bit by adding some power and bringing the nose up to control that rate of descent. Now the little trick which is useful for VTOL operations is to do sensor select down and just verify with the DMT or the T-pod if it's at night that your designated landing area, the waypoint, is exactly where you want it to be, which in this case is on the threshold, which is perfect. So we'll put this MFD back to engine. Okay, slightly high, 2 miles, 4 greens, flaps where they need to be in auto. Okay, and now we're just going to adjust for between 10 to 12 units of AOA. Adjust our rate of descent with the power and adjust our AOA with the stick. And now that we're in close, less than 2 miles, I'm using the velocity vector to aim for the threshold. So bringing the power back to adjust rate of descent, put the velocity vector on the numbers, and I'm trimming the nose to keep the witch's hat on the horizon. It's very important that the witch's hat stays on the horizon as you touch down.
Altitude.
Go.
Altitude.
Nice gentle approach, and we're going to add some power because we want to touch down at no more than 500 feet per minute. And close the throttle. Close the throttle, bring the nozzles all the way back to 90, and push the throttle forward no more than 60% RPM. This is positive nozzle braking. And we're going to let the aircraft slow down using rudder to keep it central. And once we're below 50 knots, close the throttle, bring the nozzles back to 40, and use toe brakes to slow down. And now we can turn our nose wheel steering on.
Caution.
And we can taxi the aircraft and vacate normally, turning off our anti-collision lights as we leave the runway. And at this point, we would report that we had successfully vacated the runway. We'd stop the jet, put the parking brake on, and perform our after landing checks. Okay, so to recap, a few phases. Firstly, line yourself up. I recommend doing this before 12 miles. I did a little bit late in this video. Before 12 miles at 2,000 feet. Make sure you've got your QFE set up. Make sure that you've got your course line on the EHSD to make life easier. Designate the waypoint if you like to make life easier. And then put the aircraft into VTOL master mode. At about 12 miles, start setting up. So to do that, you want to be less than 300 knots. Bring your gear down, bring your flaps to auto. Make sure your water's off if it's not needed. And then trim yourself for straight and level between 10 and 12 units of AOA. At 8 miles at 2,000 feet, this is the long finals point. If you're doing radio calls, you'd say call sign long finals to land or touch and go, whatever the case may be. For example, Ninja 1-1 long finals to land. And then you want to start descending, aiming to be at 6 miles at 1,500 feet, maintaining between 10 and 12 units of AOA, and just checkpoint yourself as you go down. At 4 miles, you want to be at 1,000 feet. Again, 10 to 12 units of AOA. Remember to use power to control the rate of descent and stick to control your AOA. So power back, so less throttle, will increase your rate of descent. Power forward will decrease the rate of descent. Stick forward will decrease your AOA, and stick aft will increase your AOA. And remember to trim to help you. 4 miles, this is the finals point. This is the point at which you would say Ninja 1-1 final 4 green, and you want to verify that your gear is definitely down and locked. Continue this, and then at 2 miles, you want to be at 500 feet, again between 10 and 12 units of AOA. Good point to verify with the DMT prior to this point that your designated landing area is where you want it to be. It's a good habit to have, not so much of an issue for the conventional landing, but when you come on to doing your short landing or vertical landing, it'll make a big difference as to how many feet away you are from the designated landing area. So you want that designation to be accurate as possible. At this point, you want to start aiming at the runway threshold itself with the velocity vector. So adjust the velocity vector to put it on the runway threshold, and adjust the witch's hat using the stick to maintain between 10 and 12 units of AOA. Once you're in close, you want to put the witch's hat on the horizon, and you want to adjust power to make sure that you have no more than 500 feet per minute rate of descent. And as you come over the runway, obviously you can close the throttle, allow it to touch down no more than 500 feet per minute. So that is the approach and the landing, and then after the landing you have the rollout, and as part of the rollout we do positive nozzle braking. So close the throttle, bring the nozzles all the way back, add power no more than 60%, allow the aircraft to slow down to no more than 50 knots using the rudder to keep the aircraft centralized on the runway. Then close the throttle, start using your toe brakes to slow down, and adjust the nozzles back to 40 degrees for taxiing. And once you've got the aircraft under control, you can put your nose wheel steering on, vacate the runway. If you have any questions about any of this, please feel free to contact me. Thank you for watching. Goodbye.